topic for this video is chemical names and formulas. The essential questions are what are polyatomic ions and how do you name and write formulas using the polyatomic ions. So poly means many in atoms, so many atoms in an ion. So that's what a polyatomic is, and it's basically prepackaged and it comes with a charge, so it's still looking to bond. Most of them are negatively charged, so they want to bond with metals. You'll want to memorize a lot of these and be familiar with the rest. Okay, so this first one is nitrate, and then we have nitrite, sulfate, and sulfite. And these four are pretty common. You'll want to memorize these. And you can start to see a pattern forming where it has an extra oxygen. It's nitrate. It ends in ATE or sulfate. And where it has one less oxygen, it ends in ite, ITE. We have hydrogen sulfate or bisulfate. The prefix bi also can stand for hydrogen. Hydrogen sulfite or bisulfite. Phosphate, phosphite, hydrogen phosphate, and dihydrogen phosphate. Okay, and I'll give you a chart that has all of these so you don't need to write all this down. Phosphate and phosphate and phosphite are two that you would probably want to memorize. Next we have carbonate, bicarbonate, chromate, dichromate, and you can remember that one because there's two chromiums on that one, Cr2O7. Next we have four different variations of chlorine with oxygen. So the ClO3 is going to be the chlorate, and one less oxygen, ClO2, is going to be chlorite. But we have a ClO and a ClO4, so we have to differentiate those as well. So we have hypochlorite, perchlorate, acetate is going to be the name we use the most. Sometimes you might see ethanoate, oxalate, iodate, cyanide, thiocyanate, and thiosulfate. And the most common ones that you may want to memorize on here are carbonate, your chlorate and chlorite, and your cyanide, and your acetate. Next we have bromate, permanganate, and these last two are very, very common. You'll definitely want to know these. OH is hydroxide, and NH4 is the only positive one we're going to worry about, and that's ammonium. Remember, NH3 was ammonia. This is ammonium. So to write the formulas, you're going to just use that crossover trick that we use for the ionic compounds. You want the charges to cancel out to zero still. So for sodium acetate, you have sodium, which is a +1, and acetate, which is a -1. They already cancel out to zero, so we can just rewrite them, and we're continuing to write the positive one first and keep the polyatomic ion all together. Potassium carbonate, potassium has a +1, carbonate has a -2, so I'm going to use my crossover trick, and I get K2CO3, that 2 goes over for the potassium, and the 1 stays with the carbonate, which remember if we have a 1 we don't write that, we just write the compound itself. Copper 2 sulfate, copper 2 tells us that that's a 2+, sulfate is a 2-, that already makes 0, so we just rewrite, and we have CuSO4. Ferric nitrate. Ferric tells us it's a +3 charge on the Fe. Nitrate is an NO3 with a -1 charge, so we do not add up to 0. We're going to do our crossover trick. And we get FeNO3, but I haven't put in the crossover yet. That's just the polyatomic ions 3. So I need to put an additional 3 there. And so that right now looks like it only applies to the oxygen, but we need it to apply to the whole NO3. So we're going to borrow a trick from math. We're going to put that in parentheses, and just like in parentheses it applies to everything, it's going to apply here. Plumbous chlorate. Plumbous has a +2 charge on lead, and chlorite is ClO2 with a -1. We're going to do our crossover trick, and because that 2 is going onto the ClO2, I have to add parentheses. So I only use parentheses if it's one of the polyatomics and there's more than one of them. Calcium hydroxide. I'm going to cross over, so that gives calcium OH2. Now right now that 2 looks like it's only applying to the hydrogen, so I need to quickly go back in and add my parentheses. This is correct, that is not. Okay, so make sure you have your parentheses in there if it's going to a polyatomic ion. A little more practice, we have ammonium dichromate. So ammonium is a +1, dichromate is a -2, and it's okay that we're combining two polyatomics. We still use the same rules of the crossover. So we start out with NH4. That 2- is going to come be the the subscript here, so I need to put parentheses here and add the 2. And then the 1 plus, well, 1 we don't need parentheses for, we're just going to rewrite the ion, Cr2O7. Silver thiosulfate. Silver we know is that +1 charge. We're going to do a crossover trick, and I get Ag2S2O3. And again, remember, we only need parentheses if the polyatomic has a subscript, and it didn't here because it was a 1. Potassium permanganate, that's a +1 -1, so that already cancels out to 0, so I can just rewrite KMnO4. Mercury 2 thiocyanate, so I'm going to do my crossover trick, and I get Hg parentheses SCN parentheses 2. Some more practice. Aluminum is a +3 and oxalate is a -2. I'm going to do my crossover trick. That gives me 2 aluminums and C2O4, and that needs to be in parentheses because I need 3 of those ions. Okay, lithium and dihydrogen phosphate. So again, this just cancels out. I got +1 -1, so I'm going to rewrite. Zinc bicarbonate, it does not cancel out, so I'm going to use my crossover trick, and the 2 is going on the polyatomic, so I have to add those parentheses around it. Stannic is +4 and sulfite is -2. So I'm going to use those crossover, but remember this time I want the lowest ratio, so I'm going to reduce it. So it would put a 2 on the tin and a 4 on the sulfite, so I'm going to reduce that to 1 and 2. To name these, you pretty much follow the same rules as the ionic compounds. You name the cation, then the anion, so it's the positive and then the negative. And then you use the Roman numerals for metals that have multiple oxidation numbers. So this is essentially just the same as it was before, except you need to now know these polyatomic ion names. So Al is aluminum and NO3 is nitrate. And aluminum only can be +3, so we don't need to worry about Roman numerals. Na is the sodium, and ClO4 is the perchlorate. Okay, and the way you tell if it's all written together like that is you go ahead and go with just the first element, name that, and the rest is going to be the polyatomic ion. There's only one exception to that, and I'm going to show you that in a second. It's actually our next problem here, NH4. If you see that, that is ammonium. So if you see that combination, and then the OH is left, and that's hydroxide. That's the only time that you will, the first name will include more than one element. Ba is barium, and then Cn is cyanide, so we got barium cyanide. A little more practice. Copper has more than one possible charge, so we need to figure out what SO4 was, and that's a -2, and since there's no other subscripts on here, it's a +2. So it's going to be copper 2 sulfate or cupric sulfate. Okay, next we have PbCrO4. Pb is lead, which also has multiple possible oxidation states. So we need to know what CrO4 is, and I believe that's a -2, so Pb has to be a +2. So it's lead 2 chromate or plumbous chromate. Fe, iron, is another one we have to watch. NO2 is a 1-, and there's 2 of those, so that means Fe has to be a 2+. So iron 2 nitrite or ferrous nitrite. And then tin is another one we have to watch for. That's going to be tin 4-phosphate or stannic phosphate. And this is how we figured this out. There's 3 tins and there's 4 phosphates. And we know all the phosphates are -3. So if there's 4 of those, that makes -12, which means these 3 together have to equal +12, and they're all going to be the same, so they're 4. We've got strontium carbonate here. Again, we're going to just name the very first element, and then the rest will be the polyatomic. This next one has a K, so that's potassium, and then we look at the rest, and that's hydrogen phosphate. Number 3 has a cadmium first, and then acetate. Number 4 has a chromium, and this is one of the ones that change. So I look at nitrate has a -1 charge, and there's 3, so it's -3. So chromium has to be a +3. Chromium 3 nitrate or chromic nitrate. Number 5, we have silver. Silver is always the same number. And then we have SCN, which is silver thiocyanate. And then number 6, we have aluminum and then hypochlorite. Aluminum hypochlorite.